Assalamualaikum warahmatullahi wabarakatuh. Hey everyone, I'm Galias Abdullah. At this moment, I will explain about nuclear theory. So, the monument on the second slide on the left is located in a museum in Japan. One of the silent witnesses to the ferocity of the atomic bomb dropped on Hiroshima. The story behind it is really sad. More than 500 children in space died in the famous atomic bomb explosion, and sadly, it happened during school hour. On this monument, there are reliefs of triangles representing the victim holding a box that say E equal mc squared. This is Einstein formula which symbolizes the atomic bomb. In the third slide, what is nuclear? Nuclear is a term related to nuclear energy, namely the form of energy released from the atomic nucleus, which consists of proton and neutron. Nuclear energy can be produced through two types of mechanisms, namely nuclear fission or fission reaction and the merging of several nuclei through fusion reaction. Nuclear fuel is any type of material that can be used to produce nuclear energy, such as uranium. How were nuclear weapons discovered? Actually, if I explain everything, I will spend a lot of time covering political and even religious and war. But let's skip into the important part. In 1938, the German scientists Otto and Fritz Strassmann discovered something that shocked the world of science, namely nuclear fission. Neutrons out of the atom can be split at a time. Otto and Fritz Strassmann conduct experiment on the uranium, one of the radioactive elements. They bombarded uranium with neutron. The result was that uranium turned into another element, namely barium, an element that is lighter than uranium. Otto didn't understand what was happening because he was just a chemist. He could only observe the reaction but didn't understand the theory behind it. So Otto sent a letter to Lisa Meitner to ask if she could explain this phenomenon. After analyzing it, Lisa Meitner concluded that the uranium nucleus had split. This was later called by Otto Fritz partner Lisa Meitner as a fission inspired by the process of the cell division in the body. The surprising part was that because the mass of some of the atom was lost and turned into energy, they calculated that based on Einstein formula, it was equal to mc squared of energy produced from nuclear division. This atom is approximately 200 MeV. However, how did Einstein formulate it? E equal mc squared. Einstein did not formulate this suddenly. It was quoted directly from his paper on special relativity with a simple picture like this. Einstein struck, what if we went on a space trip using a space shuttle and then he saw Superman, who was standing still, suddenly move and emits light in all directions in space. When Einstein was in a plane in space, Albert Einstein's general special relativity would occur. With Superman moving outside the plane, this special relativity tells us that there is different and travel time between Einstein and Superman planes out there. So, from here, we can measure the difference in the value of the frequency and energy of light. This is called the Doppler effect. In short, from the things above, the Doppler effect and relativity formula can be manipulated and substituted into the energy equation as shown in the picture on the 6 to 8 slide. So, now we discuss why an atomic nucleus this small can produce enormous power in the atomic nucleus. There are two types of particles, namely protons and neutrons. Protons have a positive charge, while neutrons have no charge. Maybe you know that if anything that has a positive charge is brought close to each other, it will definitely repel what is called the Coulomb force, as in the picture of the third slide. Well, but these protons are attacked very strongly to atomic nucleus. Why? Because they are held back by a force called strong force. According to scientists, This force is the strongest in the universe. Strong force is what causes protons and neutrons to bond tightly in the atomic nucleus like glue. Let's review our memories regarding the 10th grade chemistry lesson about atomic structure. Atoms consist of electron and atomic nuclei, namely protons and neutrons. For simplicity, atoms are denoted by X, A, and Z, where X is the type of atom, A is the atomic mass number, and Z is the atomic number, or number of proton or electron, because the number of proton and electron is the same. Now, let's get into the mass defect section. So, the nucleus consists of neutrons and protons. Logically, the mass of the neutron plus the mass of the proton will be the same as the mass of the nucleus, because the nucleus is formed from neutron and proton, but apparently not. The mass of the proton plus the mass of the neutron is greater than the mass of the nucleus. So, the component after being combined, the beginning and the end, are bigger than the beginning. When something is missing, well, the difference is a mass defect. Protons and neutrons initially form a nucleus and are then combined. It turns out that there is a difference in mass. Well, the difference is a mass defect. On the first slide, here are four nuclear functions in everyday life. First, nuclear power plant. Nuclear power plant use nuclear power as its energy source. Nuclear power plant will convert this electrical energy through the use of detector. Second is nuclear weapon, and third is cancer treatment. Radiology treatment in cancer treatment is one example that utility nuclear energy. This therapy will use radioactivity substance via injection, which are useful in killing cervical cancer. Fourth, nuclear for submarines. Nuclear submarine basically utilize nuclear reactor to process heat-shock nuclear fission reaction. Okay, that's all my explanation. I hope you enjoy and increase your knowledge. If there are any mistakes, please correct it in the comment columns. Thanks for listening. Wassalamualaikum warahmatullahi wabarakatuh.